Hello, Accelerated Math 6-7. We are working in Module 8, and this is Lesson 5. And the lesson is called Multiplication and Division of Integers. Okay. The goal for today we will learn how to use integers in multiplication and division. The question that I want you to be thinking about during the lesson is, what are the rules used with multiplying and dividing integers? All right, so we're going to get started. The first thing that we need to discuss is a little bit of a review in things to remember. And I want you to think back a while, probably close to around third grade. And in third grade, you learned how to multiply. So what we are talking about in multiplying is maybe one thing that you were taught is that the first number in a multiplication expression told you the number of groups. So we're going to look at this 3 right here, and this 3 is going to be labeled as the number of groups. Okay, and the second number always told us the numerical value. So it means what number was being multiplied. So this is the numerical value. And so basically, if you were to read this expression, it says 3 groups of -5. And you have to remember that multiplication is the same thing as repeated addition. So basically it's saying that you have 5 negatives plus 5 negatives plus 5 negatives because you have 3 groups of -5. So we have 5 negatives plus 5 negatives plus 5 negatives. That's what this problem right here is saying. Okay, so then if we, because multiplication is commutative, we can swap the numbers that are being multiplied, and so now 5 would become the number of groups, okay, and -3 would become the numerical value. And then what this one is saying now is that we have 5 groups of -3. So you would have -3 plus -3 plus -3 plus -3 plus -3. Now, so this is telling us what the value is. This is telling us how many groups. This is telling us what the value is. This is telling us the number of groups. And since, again, like I said, multiplication is the same thing as repeated addition, we can now easily, using the chip model or the number line, figure out what the answer is very quickly. And if you have -5 plus -5 plus -5, let's say there's 5 groups of red chips, 5 pieces of red chips, 5 pieces of red chips, 5 pieces of red chips, you can go 5, 10, 15, and they're all red, so that means the answer would be -15. Same as doing it over here, you have 3 pieces of red chips, 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 and then you would say 3, 6, 9, 12, 15, and they're all red, so they would be negative. Okay, so that's a really easy way to visualize what is happening. All right, so if we're remembering that from about third grade, except you didn't do integers in third grade, you just had positives, the question that I want you to ask yourself is, can you have negative groups? Okay, we've been talking about this a little bit, and in the last couple of lessons, I told you that you can't take away a negative, and the reason why you can't take away a negative is because it doesn't exist. So the question that we have to think about on this one is, can you have negative groups? Well, the only time that I would say that you can have negative groups is if you use the number line, and that negative on the groups would tell you the direction that the arrow needs to go. And so the way that we can try this and see if it works is you draw a number line, okay, and we always start at 0, so here's 0, and then this says that we are going 3 groups to the left because this says negative. So on the number line, this is telling us we need to go, you can't even see it, sorry. Okay, 3 groups to the left because this is negative. And so this is still the number of groups. This tells us how much the numerical value is. And so we would say the arrow needs to be 5 units long. So this is going to tell us arrow length, right? And then this one is going to tell us that we have to go to the left on the number line because the groups are negative. So left on the number line, left on number line. Okay, so now we're going to try it. So here's 0, and I'm supposed to go 1, 2, 3, 4, 5, right? And then I'm supposed to do that how many times? 1, 2, 3, 4, 5. And then I go 1, 2, 3, 4, 5. And now I'm going to put my arrows in so that we can see it. So we have start on 0, 1 time, 2 times, 3 times. And so our answer to this problem is negative 15. Okay, so now let's try this one. Again, we're going to use the number line. And this time it says that our arrow length needs to be 3, and we need to go to the left 5 times. Okay, so here's 0, 1, 2, 3, or 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and now let's do this. So we start at 0, go to the left 3, go to the left 3, that's 2, go to the left 3, that's 3, go to the left 3, that's 4, and go to the left 3, that's 5, and that was 5 times. So our answer is still negative 15. All right, and so if we have negative groups, the thing that I want you to remember about it being called a negative group is that it's telling you which direction to go on the number line. So this negative symbol right here is saying go left on the number line 3 times. Go left on the number line 5 times. And so that's how you can say that. I don't know if we could actually constitute that that would be negative groups, but I would rather you think about it as a direction on the number line. Okay, so going left on the number line represents the negative group's number. All right, what happens when your group number and numerical value are both negative? Okay, so when they are both negative, something that you can use to help you figure this out is, remember to label it. So this right here is our number of groups, right? And this right here is our numerical value. And so something that you can think about, that idea up there on the number line is that you're going to the left, is we could also think about this as a loss of 3 groups of negative 5. A loss of 3 groups of negative 5. And so I want to draw a picture of that because we're going to actually show you how to do this with the chip model. So I'm going to turn the page. And so it's negative 3 times negative 5. And so I'm going to write that right here. Negative 3 times negative 5. Okay, and it says on our next page, in order to take away the negatives, you must have some. Use 0 pairs. So we're going to draw 0 pairs. So this says right here that this is the number of groups and this right here is your numerical value. And so we're working with negative 5s. Okay, but in order to do that, we have to get some. And you can't just make numbers appear. You actually have to start with something. And remember how I said we always start with 0. So I'm going to do 1, 2, 3, 4, 5 positives. But I notice up there we said to use 0 pairs. So I'm going to do 5 negatives. And by doing that, I've created 5 0 pairs. Then I'm going to do it again. 1, 2, 3, 4, 5. Again, those are positives, so I have to make them 0 pairs by doing the negatives. Okay, and then one more time. 1, 2, 3, 4, 5 positives. And then 0 pair it, so I'm doing negatives. Okay, now some of you are probably thinking, why is she doing 0 pairs? Well, the reason why you have to do 0 pairs is because you can't just say a number exists. You have to actually have it there. So we have 3 groups, no, three groups that have to be taken away because of this negative right here. And then the numerical value is -5. So it says that it's a loss of three groups of -5. So a loss means that they go away. So if we didn't do zero pairs, we wouldn't have the negatives to take away. And so we have to do zero pairs so that they can exist. And then we take away the -5 because it says a loss of three groups of -5. And so basically what you're doing is you're scooping up all of your negatives and you're taking them away. Take away. Okay? All of your negatives and take away. Because up above, that math sentence says that you're taking three groups of -5 away. Okay? And the reason why we know that it says it is because -5 is the numerical value, 3 is the number of groups, but this little negative sign right here means a loss or to take them away. So I'm scooping them up and taking them away. Then your job is to figure out what do you have left after you've done all of that work, and we have 5, 10, 15 positives left. So the answer to this problem is +15. Okay? Now, that kind of seems a little bit crazy, doesn't it? But that's exactly how you have to do it when you have both numbers being negative numbers or negative integers. Okay? And so it's really important. It seems like a lot of work, but you do have to do this. So to review, when you have a negative group number and a negative numerical value, you always use zero pairs when you're working with the chips. Always use zero pairs. And then you take away what it asks you to. Okay, so then there's one other thing that we need to talk about is if you have to do this with division. And the thing that you have to think about with division is we just found out that if you have a negative value up here and a negative value up here, what did we end up with as the answer? The answer was a positive. Okay, so what if you start with a +15, okay, and you're dividing a -3, okay, and I want you to look at that, and I want you to compare what you see from what we did up above. And my question to you is, couldn't we say that this math expression right here is the opposite of this up here? Because we have a 15 as the answer, which happens to be right there. Divided by is the opposite of multiplying. And then -3 is sitting right there. So what does our answer have to be? Our answer has to be a -5 because we've now learned the fact family rule that the family members for this problem are 15, -3, and -5. And you can't change the family members that make up the expression. And so since we learned that when you get three groups that have to be taken away of -5, you get an answer of 15, the family members automatically become 15, -5, and -3. So whenever you have 15, -5, and -3, you know that those three are the only three family members for that fact. And so whenever you see 15 divided by a -3, you know the missing family member is -5. Okay? And that's how you remember it. All right? So thinking about those fact family rules that you learned all the way back in 2nd or 3rd grade could help you with that as well. All right? We're going to do a lot of practice with this in class, so don't panic if it still seems a little bit difficult. But let's go back and discuss our goal one more time. Today, we will learn how to use integers in multiplication and division. And then we did that. And then what are the rules used for multiplying and dividing integers? Well, the rules that we learned is if we label them as to what they are supposed to be, and then show it with chips or on the number line, then you can figure out what the final answer would be. All right? And that's all I I have for you today.